Adding and subtracting radical expressions. Our objective is to add and subtract radical expressions. Why learn this? You can add or subtract radical expressions to find perimeter. So let's look at like radicals and unlike radicals. So a like radical has the same radicand. So like this one's the square root of 5 and the square root of 5. Square root of x, square root of x. Square root of 4t, square root of 4t. So the radicands are the same, which makes them like radicals. Unlike radicals, either one has a square root and the other one doesn't, or they're not the same underneath the square root symbol. So the radicands are different. Like this one's x and that one's 6x. This one's 2 and that one's 3. So if you think back to combining like terms, when things were like terms, you could add or subtract them. Well, if you have like radicals, you can add or subtract them. Like 2 and 4 make 6, so we have 6 square roots of 5, because it's a 5 and a 5. Our radicands here are x and x, so we can subtract them to get 4 square roots of x. Let's try a few examples. So in this first one, we have 3 square roots of 7 plus 8 square roots of 7. Our radicands are the same, so we can combine them. 8 and 3 give us 11, and we have the square root of 7. So now let's look at b. We have 9 square roots of y minus the square root of y. If it helps, you can put a 1 in front. So we have 8 square roots of y minus 1 square root of y, which leaves us with 8 square roots of y. C is a little bit tricky. We have 12 square roots of 2 minus 4 square roots of 11. Our radicands are not the same, so we cannot simplify this. We can't just simply add or subtract them together unless our radicands are the same. So your answer is what it started as, 12 square roots of 2 minus 4 square roots of 11. Now let's look at d. We have negative 8 square roots of 3d plus 6 square roots of 2d plus 10 square roots of 3d. Our like terms, we can combine them, or our like radicals. So we have 2 square roots of 3d plus 6 square roots of 2d. And these don't have like radicands, so we can't combine them. So that is your final answer. Take a moment and pause the video and try these next 4 on your own. When you return to the video, the answer for each will be revealed below. And there you have it. Sometimes radicals do not appear to be like until they are simplified. So like these appear to be like, these ones are like, these ones are unlike, but we can't simplify them. So some of the future ones we're going to do, we can simplify all radicals in an expression and then look to see if any of them are like radicals. So let's take a look. For example, we have the square root of 12 plus the square root of 27. At first glance, there's nothing we can do. They don't have like radicands. So since they don't have like radicands, we can't just add them together and end up with 12 and 27. But we can simplify the square root of 12. So when we simplify the square root of 12, we end up with the square root of 4 times the square root of 3, which gives us 2 square roots of 3. And for the square root of 27, we can separate that into the square root of 9 times the square root of 3. And the square root of 9 is 3, and we can't do anything with the square root of 3. So now that we've simplified each of our terms, now we have like radicands, so we can add them together. So we end up with 5 square roots of 3. Let's look at b. At first glance, there's nothing we can do. However, we can simplify the square root of 8, and we can simplify the square root of 45. So when we simplify 8, we can break that down into the square root of 4 times the square root of 2. The square root of 4 is 2, and we can't do anything with the square root of 2. So we're going to just rewrite it. Now, don't forget about this 3. That 3 kind of gets to come along for the ride. So we now have 6 square roots of 2 for our first term. Now let's look at our second term. We can break 45 up. We can break it up into the square root of 9 and the square root of 5. The square root of 9 is 3, and the square root of 5, well, it's going to have to stay as the square root of 5. So our second term is 3 square roots of 5. Even after simplifying, their radicands are not the same, so we can't go any further. So our end result will be what you see here. 6 square roots of 2 plus 3 square roots of 5. Take a moment and pause the video and try C and D on your own. When you return to the video, the answer will be revealed. Okay, so this first term, we can break that down. So we have the square root of 28x. That breaks down into the square root of 4 times the square root of 7 times the square root of x. We know that the square root of 4 is 2. So 5 times 2 is 10, and we can't do anything with the square root of 7 or the square root of x. So we're going to stick them back together underneath our square root symbol. We cannot simplify 8 square roots of 7x. So we're simply going to bring that down and rewrite it. So now we have 10 square roots of 7x minus 8 square roots of 7x, leaving us 2 square roots of 7x in the end. D was a bit trickier, so we had to simplify all 3 terms. So 125 breaks down into 25 and 5, and then we have this b. The square root of 25 is 5, and we can't do anything with the square root of 5 or the square root of b, so we're going to stick them back underneath. Now we have our second term. We can break down 20 into the square root of 4 times the square root of 5. Don't forget about that square root of b there too. The square root of 4 is 2. We can't do anything with the 5 and the b, so we have the square root of 5b. Now, common error, don't forget about the 3. It's got to come along for the ride here, just like the 5 did over here. So we have 3 times 2, which is 6. So we have 6 square roots of 5b. And the third term. We can break our 45b down into 9, 5, and b. The square root of 9 is 3, and we can't do anything with the 5b, so we have the square root of 5b. And now we can combine our like terms. They are all like radicals, so we have 5, 6, and then subtracting 3, which brings us to 8. So we have 8 square roots of 5b. Let's try a geometry application. So we want to find the perimeter. Perimeter is to add up all the sides. So we're going to give our answer in a radical expression in simplest form, also known as simplest radical form. So we want to add up all of our sides. So we have 5 square roots of 7 plus the square root of 28 plus 12. We can't simplify 5 square roots of 7 at all, and there's nothing we can do with the 12 right now. However, we can simplify the square root of 28. We can break the square root of 28 down, so we have the square root of 4 times the square root of 7. The square root of 4 is 2, so we have 2 square roots of 7. Since we couldn't do anything with 12, we're going to rewrite that. And since we couldn't do anything with the 5 square roots of 7, we're going to rewrite that as well. And now we can combine our like radicals. So we have the square root of 7 and the square root of 7. So 5 and 2 make 7. So we end up with 7 square roots of 7. And then this 12 is just chilling out off to the side because we can't combine it with anything. It doesn't have a radical to combine. So our perimeter is 7 square roots of 7 plus 12. And that ends our lesson on adding and subtracting radical expressions.